through it. So it has to be a solid object going right through the corona. And yeah, it's just amazing.
Yeah. He said like the sun is discharging with its, and is exact opposite of what we see the Nemesis star, which is more of a magnetic field. It's in its charged state. So like,
yeah, that's right. So these objects have very high magnetic fields, and of course, if you have a magnetic field, you have an electric field. So, you know, I believe that stars have electric potential energy. And what happens to these brown dwarf stars when they start the aging process, they start running low on energy. And eventually the brown dwarf star is extremely low on energy, and it can barely ionize its gaseous envelope. But then when it comes into the solar system and comes in contact with the sun, it starts absorbing electric potential energy from the sun. And then it still has its magnetic field, but they're not as high as white dwarf as it was in its white dwarf state. So they have to actually go into the sun's corona to pull plasma from a main sequence star. Whilst white dwarf stars can do it from quite a distance, say from 1 AU, a white dwarf star, the white dwarfs are able to pull plasma from a main sequence star from about 1 AU distance.
And a white dwarf star, does that have just a stronger magnetic pull? That's why it can do it from a greater distance?
That's right. It's got a much higher magnetic field. It's also much smaller. Don't forget, white dwarf stars are about the same size as the Earth. They are extremely dense and they have very high magnetic fields. Whilst the brown dwarf stars are about the size of, but they're a little smaller, maybe a little larger, but about the size. They're a lot larger than white dwarf stars. So from that observation and comparing the brown dwarf stars with the white dwarf stars, I came up with the idea that mass is not intrinsic property. We always think an object will always have the same mass, but its electric field may change according to circumstances. Well, it turns out that the mass is always is also changing like the electric field according to circumstances. So that's what I mean by it's not intrinsic.
Right.
Yeah, so this is, I've discovered that by comparing white dwarf stars with brown dwarf stars, that if they increase in size and their mass decreases, it means mass is not intrinsic. And just like the magnetic field drops, the mass of the object also drops, and its size increases. So it's quite, yeah.
Okay. I was studying plasma physics, and in some of the examples I've seen during the plasma experiments, that they were using magnetic balls showing the property of magnetic fields and that can be induced into balls. And one thing I found interesting was that two magnetic fields, if they're far apart, repel each other until they get to a distance and then they attract.
Yes, that sounds correct. I think that's what would happen, because the magnetic field lines try not to overlap each other, and that would cause a repelling. But if they are forced together, what you then get is a reconnection of the magnetic field lines, and then they would attract each other. Yes.
Right. So I wonder what it must be the spin nature. Do they have like a spin to it? Probably very fast, wouldn't it?
Yes, I think there's spinning happening in these plasma fields, definitely, because we see that